What is light? Light is a form of energy that our eyes can detect. It's a type of electromagnetic radiation, which means it's made up of tiny particles called photons that travel in waves. These waves move really fast, about 186,282 miles per second, 299,792 kilometers per second, which is why light can travel from the Sun to Earth in just a few minutes. Light comes in many colors, and when different colors are combined, they create white light. Our eyes see this light, and our brain interprets it, allowing us to see the world around us. Light can also be reflected, refracted, or bent, which is why it can be used in various ways, such as for illumination, communication, like fiber optics, and even to see distant objects through telescopes. Name 3 things that give out light. Sun. The Sun is a natural star that emits an enormous amount of light and heat. It is the primary source of light for our planet and the reason we have day and night. Light bulbs. Electric light bulbs, such as incandescent bulbs, fluorescent tubes, and LED lights, produce artificial light by passing an electric current through a filament or semiconductor material, which emits light in the visible spectrum. Fire. When certain materials, like wood or paper, burn, they produce flames that give off light and heat. This is a chemical process where the heat causes the material to emit visible light. These sources of light are essential for various purposes, from providing illumination to allowing us to see and carry out activities in the dark. What are luminous objects? Luminous objects are objects that emit their own light. In other words, they produce light as a result of a chemical or physical process occurring within them. Luminous objects are sources of light themselves, as opposed to non-luminous objects, which can only reflect or transmit light from another source. Examples of luminous objects include stars. Stars are some of the most well-known luminous objects in the universe. They emit light and heat through nuclear fusion in their cores. Light bulbs. Electric light bulbs, whether incandescent or LED, are designed to emit light when an electric current passes through a filament or semiconductor material. Bioluminescent organisms. Some living organisms, such as fireflies and certain types of deep-sea fish, are bioluminescent. They produce their own light through a chemical reaction in their bodies. Luminous objects are essential for providing illumination and enabling us to see in the absence of natural light sources. What are non-luminous objects? Non-luminous objects are objects that do not emit their own light. Instead, they become visible by reflecting or transmitting light from a luminous source, such as the sun, a light bulb, or any other light-emitting object. These objects are visible to our eyes because they interact with and redirect the light that falls on them. Here are some examples of non-luminous objects. Tables and chairs. Everyday objects like furniture are non-luminous. They are visible because they reflect the ambient light in a room. Rocks and mountains. Geological features do not produce their own light but are visible due to the sunlight or artificial lighting that illuminates them. Books and paper. Printed materials do not emit light themselves. Instead, they are readable because they reflect light from a light source or room lighting. Human beings. Humans are non-luminous objects. We become visible in the presence of light because our skin and clothing reflect or scatter the light around us. Non-luminous objects make up the majority of the objects we encounter in daily life, and they rely on external light sources to be seen. What can light travel through? Light can travel through a variety of materials, depending on their properties. The ability of light to pass through a substance is influenced by its transparency, which is a measure of how much light can transmit through it. Here are some categories of materials that light can travel through. Transparent materials. Transparent materials allow light to pass through with minimal absorption or scattering. Examples include clear glass, air, water, and some plastics. These materials do not significantly obstruct the passage of light, allowing you to see objects clearly through them. Translucent materials. Translucent materials permit some light to pass through, but they scatter and diffuse the light, making it less clear. Examples of translucent materials include frosted glass, wax paper, and certain types of plastics. While you can see that there is light on the other side, you cannot see distinct shapes or details. Fiber optics. Fiber optic cables are designed to transmit light over long distances with very little loss of intensity. They use total internal reflection to guide light through the core of the cable, making them suitable for high-speed data transmission. Certain glasses. Glasses like air, oxygen, and nitrogen are generally transparent to visible light. This is why you can see through the air, allowing you to see objects at a distance. Vacuum. Light can travel through a vacuum, which is a space devoid of matter. In outer space, where there is essentially no matter, light from the sun can travel great distances without obstruction. It's important to note that the degree to which light can travel through a material varies based on factors such as the material's composition, density, and thickness. Explain transparent, translucent, and opaque objects. Objects can be classified into three categories based on how they interact with light: transparent, translucent, and opaque. Transparent objects. Transparent objects allow light to pass through them easily. When light travels through transparent materials, it is not significantly scattered or absorbed. Examples of transparent objects include clear glass, clean water, and some types of plastics. You can see clearly through transparent objects because they transmit light without distorting the view. Translucent objects. Translucent objects allow some light to pass through, but they scatter and diffuse the light. Light passing through translucent materials is not clear and is often diffused or muddled. Examples of translucent objects include frosted glass, wax paper, and some types of plastic sheets. You can see that there is light on the other side of translucent objects, but you can't see distinct shapes or details. Opaque objects. Opaque objects do not allow light to pass through, they block or absorb light. When light encounters opaque materials, it is either absorbed or reflected, and no light travels through. Examples of opaque objects include wood, metal, and most solid walls. You cannot see through opaque objects because they prevent light from passing. Understanding the transparency of different objects is important in various fields, such as optics, architecture, and design, as it influences how light interacts with and travels through materials. Name 3 things that you can see through. Here are 3 things that you can see through, as they are transparent. Window glass. Glass windows in buildings or vehicles are typically transparent, allowing you to see outside while still providing protection from the elements. Clean water. When water is pure and clear, you can see through it. This is why you can see objects beneath the surface of a swimming pool or a glass of clear water. Clear plastic. Some types of plastic, such as clear acrylic or certain packaging materials, are transparent, enabling you to see objects on the other side. These transparent materials allow light to pass through with minimal distortion, making it possible to see objects on the other side. Name 3 things that you cannot see through. Here are 3 things that you typically cannot see through as they are opaque. Solid walls. Solid walls made of materials like brick, concrete, or wood are opaque and block the passage of light, preventing you from seeing through them. Metal. Most metals, like steel or aluminum, are opaque and do not allow light to pass through. They are often used in building structures, vehicles, and various objects where opacity is required. Wooden doors. Solid wooden doors are typically opaque and do not allow you to see through them, as they are designed to provide privacy and security. Opaque objects do not transmit light and are used for various purposes, including providing privacy, structural support, and security. What colors are light made up of? Light is made up of a combination of different colors. The colors of light are often described in terms of the visible light spectrum, which includes a range of colors. These colors, in order, are: red, the longest wavelength and lowest frequency in the visible spectrum; orange, slightly shorter wavelength and higher frequency than red; yellow, shorter wavelength and higher frequency than orange; green, shorter wavelength and higher frequency than yellow; blue, even shorter wavelength and higher frequency than green; indigo, a less common color in the spectrum, falling between blue and violet; violet, the shortest wavelength and highest frequency in the visible spectrum. When these colors are combined, they create white light. You can see this effect when you shine light through a prism, which will split the light into its various colors, creating a rainbow of colors. Each color corresponds to a specific range of wavelengths within the electromagnetic spectrum. What is refraction? Refraction is when light bends as it passes through different materials, like air, water, or glass. This bending happens because light travels at different speeds in different materials. When light goes from one material to another, it can change direction, and this is what we call refraction. An easy way to understand it is to think about how a straw looks bent when you put it in a glass of water. The light coming from the straw is bending as it moves from the water into the air. Give an example of refraction. One common example of refraction involving a prism is the way white light, which is made up of various colors, bends when it passes through a glass prism. When white light enters the prism, it slows down and bends due to the difference in the speed of light in air and glass. The amount of bending or refraction depends on the wavelength of each color in the white light. As a result of this bending, the white light gets separated into its individual colors, creating a spectrum of colors, such as a rainbow. You can see this effect if you shine white light through a prism. The light entering the prism will be bent, and you'll observe a beautiful display of colors on the other side, with red, orange, yellow, green, blue, indigo, and violet arranged in a linear fashion. This phenomenon is a classic example of how refraction can disperse light into its various components based on their different wavelengths. What is dispersion of light? Give example. Dispersion of light is the phenomenon where white light is separated into its constituent colors or wavelengths, creating a spectrum of colors. This separation occurs because different colors of light have different wavelengths and are bent by different amounts when passing through a medium, such as glass or water. Dispersion is often associated with the use of prisms or other transparent materials that can refract, bend, light. An example of dispersion of light is a rainbow. Rainbows occur when sunlight is refracted, bent, and internally reflected within raindrops in the atmosphere. This bending and internal reflection cause the white light to separate into its component colors, forming a beautiful semicircular arc of colors in the sky. The different colors of the rainbow, typically arranged in the order red, orange, yellow, green, blue, indigo, and violet, are a result of the dispersion of sunlight by the water droplets in the air.